So I'm here to give you a brief summary of the science behind the mRNA vaccine. So traditionally, vaccines take a really long time to produce, a minimum of 2 years until they go into clinical trials. And why is that? That's because you still have to get the virus, you have to culture the virus, and then you have to purify the virus, inactivate the virus, and then administer the virus to animals, and then you go and you try them on humans. So scientists were not happy about this. It's not something new. They didn't wake up suddenly in 2019 or 2020 and go, oh my God, vaccines take so long, let's do something about it. That did not happen. So 15 years ago, there's a doctor called Dr. Drew Weissman in the University of Pennsylvania. He had an idea. He thought, instead of going through all this process, let's just give the human body the RNA, and then the body can make the protein of the virus just easier and faster and cheaper. So that's what he did 15 years ago. He tried it. He injected some animals with this mRNA vaccine. But what happened? The animals had a severe inflammation. So his colleague, Dr. Catalan, found a way to modify the RNA structure so the body will not react to it in a negative way. Next, we had to find a way to encapsulate the RNA. Why? Because if you just inject RNA into your body, it's not just going to stay there. It's not going to go inside of your cells, which is where we needed to go. So they put a fat coating around this RNA. They tried this with the RSV virus. They've been trying to make a vaccine for this for many, many years, and they kept failing. But it worked with the mRNA technique. So next, they focused on the MERS virus, which is part of the coronavirus family. This was all done under BioNTech. Pfizer then saw this and were very interested. And so they made a partnership with BioNTech to start working on a flu vaccine that is mRNA based. That happened in 2018. When the COVID-19 happened, they switched gears. They focused on the COVID-19. And all that they needed was the genome of the virus. And it was released in January of 2020. So how does mRNA vaccines make vaccine production much, much faster? Imagine you are a printing company. You've been trying to find a way to print books. You figured out how to get the proper type of paper, the proper type of ink. Then you tried to find a way to glue the pages together. And then you found a way to put like a cover on it. So next time somebody tells you, I want to publish a book, it's not going to take you a long time to do it. You've already done all the research. The only thing that's going to be different is what's inside of that book. And this is why mRNA vaccines are revolutionary. So they're going to make vaccine production much, much faster. So nowadays, what do companies really need to do? They just need to check the mRNA vaccines to see how long they give you immunity. They might give you 6 months, 1 year, 1 week, 2 weeks, 2 months. That's what all they need to check right now. I hope now that you see how much research was put into this mRNA vaccine.